Section 6.4, Probability. In this lesson, we're going to be discussing the terminology involved with probability and calculating the probability of an event. So some of the terms that we're going to discuss and use throughout this lesson on probability include the term experiment, which is an activity in which the result is considered to be random in nature. So when we talk about experiments here, we're talking about random experiments. The outcome, that is an individual result from an experiment. The sample space is the set of all possible outcomes of an experiment. And then an event is some or all of the outcomes from the sample space. And those are usually what we're going to be trying to find, is the probability that some event will occur. One of the ways that you can look at doing probability is to use a tree diagram to help you determine what are all your outcomes. So let's say that we have a coin that we're going to toss twice. We're going to draw a tree diagram to illustrate the experiment, and we're going to list all the possible outcomes in the sample space. So if we toss a coin, we're assuming we have a fair coin, which means that we have the same probability of it turning up heads as it does tails. The first toss, we have two possibilities. It could come up heads or it could come up tails. Then the second time that I've tossed the coin, you have the same probability of heads and tails again. So now we'll list what would be all of our possible outcomes, and that makes up the sample space. So we'll say the sample space would be, well, the first thing that could happen is we could have heads on the first coin and heads on the second coin. So we'll list that as HH. Then the second one, it could be heads on the first one, tails on the second flip. So that'll be HT. Our third possible outcome would be that we could have had tails on the first flip and then heads. So we would list that as TH. And then the last possible thing that could have happened was we could have had tails on the first flip and then tails on the second, which would be TT. Each of those makes up an event or a possible outcome, and the entire set of outcomes would be the sample space. Now we'll do the same thing, but now we're going to assume that we toss it 3 times. So we'll have heads, tails. On the second flip, we could have heads and tails for each of our other 2 possibilities. And on the third flip, we could then have heads and tails again. Since these are said to be independent events, that one does not depend on the other, each time we have heads and tails. So now our sample space would be made up of, well, the first thing is we could have all heads. The second one would be heads, heads, tails. Then we'd have heads, tails, heads, heads, tails, tails. Now we're on this branch, tails, heads, heads, tails, heads, tails. Then we have tails, tails, heads, and tails, tails, tails. Now, I do want to point out that there is a quick way to count up the total number of possibilities. If you look, you have a total of 8 possible outcomes here. One way we can find that is to look at each individual event and find how many outcomes that each one of those have, and then multiply those. So in the first toss, we had 2 things that could happen. In the second toss, there were 2 more things that could happen. And in the third toss, there was 2 more things that could happen. So that gives me a total of 8 different events or outcomes. And notice that we had a total of 8 possible outcomes in our sample space. Now let's look at a 6-sided die, and we're going to roll it and look at all the possible outcomes. Well, in a 6-sided die, there are 6 outcomes. So we could roll a 1 or a 2, 3, 4, 5, or 6. So there would be 6 different outcomes, and then we would say that our sample space would just be the numbers 1 through 6. Now let's talk about how to find the probability of an event. So to find the probability, what we're going to do is we're going to make a ratio or a fraction, and we're going to take the number of outcomes in the event divided by the total number of outcomes in the sample space. So how many ways what we want to occur can happen, that's the number of outcomes in the event, divided by the total number of outcomes that could happen altogether. So let's look at this one. A coin is tossed twice. Find the probability that both tosses are tails, tails. So if you go back to what we previously did with our first tree diagram, remember that it went like this. So there is a total of 4 outcomes in our sample space. So that's the total number of outcomes. And how many ways can we get tails, tails? Well, there's only one way that can happen. That would be this branch. So it would be 1 in 4 would be our probability that we're going to toss the 2 coins or toss a coin twice and get tails, tails. So now let's look at a die problem. So you're going to take a die and roll it once. We want to find the probability that we'd roll an even number. So if we roll a die once, assuming that this is a normal cube for a die, then we're going to have 6 outcomes. And if we look at how many of those would be even numbers, how many different ways can we get an even number? Well, we'd have a 2, a 4, and a 6. So there's 3 even numbers. So we want the number of ways we can get the event, which would be 3, divided by the total number of events in our sample space. So that would be 3 over 6, which would simplify to 1/2. So our probability of rolling an even number is 1 to 2, or 1/2. Let's look at probability now using a standard deck of cards. So if you're not familiar with cards, a deck of cards, taking out the jokers, has 52 cards. There are 4 suits. There's hearts, diamonds, spades, and clubs. There's 13 of each suit. And your cards are ace, king, queen, jack, and then the numbers 2 through 10 in each one of the suits. So we're going to draw one card from a deck of cards, and we want to find the probability of each of the following events. So let's first of all look at what's the probability that our card will be a 10. Well, we know that we have 52 possible outcomes in our sample space. There's 52 cards. And now I want to do is find out how many of those are 10s. Well, 4 out of 52 of the cards are 10s, and 4 out of 52 would reduce to 1/13. Now, for B, what's the probability that our card is a diamond? Well, again, we've got 52 possible outcomes, and a diamond can occur 13 different times since there are 13 cards in each suit. So my probability of getting a diamond is 1 in 4. And for C part, what's the probability that our card is a 2 or a 3? So again, this is going to be 52 as our total number of outcomes. A 2 or a 3, well, we've got a 2 in all 4 suits and a 3 in all 4 suits. So there's going to be a total of 4 2s and 4 3s, which means there's 8 out of 52 as our possible outcomes. But then we can simplify that. One way we can do that is just go ahead and divide both of those by 2 and get 4 out of 26. But then those are still even, so we could divide by 2 again and get 2 out of 13. Now we'll look at a word problem. Hugo is buying a new car and has determined the make and model he wants to buy. He now needs to decide on the colors of the interior and the exterior of his car. He can choose from blue, white, red, black, and silver for his exterior, and gray, beige, and black for the interior. So for A, how many color combinations does Hugo have to choose from? So remember what we said a minute ago, since we have two different choices here, interior and exterior, if we multiply the number of choices for each one of those, that gives us the total number of choices. So for his exterior, he has 5 choices. And for his interior, he has 3. So there's a total of 15 different color combinations that he could choose from. So what's the probability that he's going to have a blue exterior and a gray interior? Well, there's only one way he could get a blue exterior and a gray interior, so his probability would be 1 in 15. Now, what about the probability that he chooses a red exterior? Well, there's a couple ways you can look at this. So if he has a red exterior, then that means that there would be a gray with red, a beige with red, and a black with red, which would make it 3 out of 15, which is 1/5. Or another way you can consider this is, since we're only looking at the exterior of the car, the interior doesn't matter anymore. And if I look at just the exteriors, there's only 5 choices for exteriors, and red is one of them. So his probability of getting a red exterior would be 1/5. So either one of those methods will solve that problem correctly. At this time, I would like for you to turn in your books to page 239 and work on problems 7, 8, and 10. We'll go over these answers in class, and I'll answer any questions you have about either these problems or the videos.